All right, guys. So we're gonna have our first lesson on sheet metal today. So hopefully you guys can see me all right. First of all, what is sheet metal? All right. Sheet metal is it's a sheet of metal, obviously. Uniform thickness all the way throughout, typically less than a quarter of an inch. Anything over a quarter, and even a quarter inch, in my opinion, is a little thick for sheet metal. But anything over a quarter inch is considered metal plate, and processes dealing with that are a little different. All right, so we're mainly looking at sheet metal. Sheet metal is typically not structural. The main purpose is for like enclosures or encasings and stuff like that. Most of our tools in the shop have some sort of enclosure made out of sheet metal to help protect the inner workings of everything. Things like electrical boxes, we've seen those. Those are typically folded out of sheet metal. And honestly, all the brackets, like if you have a deck or anything like that, all those little metal brackets that hold all the wood structures together, typically are sheet metal stamping. So it's used widely in the industry. It's used widely throughout construction and metal fabrication. So it's a very versatile material, and it's very there's just separate processes on how to shape it, bend it, and all that kind of stuff to make sure you get your desired shape. Sheet metal does come in varying thicknesses. What you see right here, I believe this is 22 gauge sheet metal, which means it is 0.03 inches thick, or 30 thousandths of an inch thick. The gauges typically run probably up to maybe from a gauge like 2, which would be very thick, a gauge 3, which would be very thick, to maybe like a gauge 30, which would be really, really thin. At some point, you get to like tinfoil in terms of thickness. So it's kind of weird though. The gauges itself, the smaller number is a thicker gauge. All right, think about that. The smaller number is a thicker gauge. So gauge 4 piece of sheet metal is going to be thicker than gauge 22. And the reason for that, see if I can get this to work. The reason for that is how it used to be covered. All right, so way back in the day, if you had a quarter-inch thick piece of sheet metal, that was called 4 gauge or gauge 4 sheet metal. All right. And now if you had a piece of sheet metal that was, let's say it's 1/10 of an inch, that would be 10 gauge sheet metal. And the reason why the smaller number is technically the thicker piece, if I was to, as we know, a quarter inch is larger than 1/10 of an inch. If I was to divide this piece into 4 perfectly even pieces of a bar, into 4 even pieces, this piece, and I would divide this bar into 10 even pieces. I'm not going to actually do all this. You'll get the point. In the 10 even pieces, we know that a quarter inch piece, this is going to be larger. This one piece right here is going to be larger than this. So that's why the smaller number is the thicker piece, because they're referencing fractional dimensions. All right. And the bottom number in the fraction, the smaller the bottom number in the fraction, the larger that fraction is. All right. Now, that's no longer the case. We've been able to manufacture, we've gotten really good at manufacturing sheet metal, and the processes here. So 4 gauge sheet metal is not a quarter inch. It was at one point, decades and decades ago. Now it's it's much different. You don't need to memorize gauge thickness. You just need to know that concept. All right. The smaller number is thicker. The larger number is thinner. It's the same with wire. It's the same with if you fish. It's the same with fish hooks. A size 20 fish hook is going to be smaller than a size 12, and then a smaller than a size 4. So it's the same process. I just want you to have a reference of where those numbers are coming from. You could always look up a sheet metal gauge chart. Let me move my face here. Might be difficult for you guys to see, but you can just type in sheet metal gauge chart. And you could see here, so like 4 gauge right here is 0.2242 inches thick. All right, so 4 gauge is not a quarter inch. That's not the way it works, but that's where where those numbers come from. we're dealing down here is 22 gauge, which is 0.0299 or 0.03 inches thick. And so that's the kind of stuff we're using around here. Just a reference for you guys. All right, let's get into some definitions here. The definition of a hem line. So oftentimes when you're dealing with sheet metal, this edge right here is going to be pretty sharp. I've cut myself countless times on these kind of things. These corners are very pointy, very sharp. So typically is what we do if you're going to have a product for an end user, all right, you want to bend this edge over real quick to make sure that it's not as sharp of an edge. So for something like that, I'll show you guys, if you guys can look right over here. Sorry, that's not it's as big as I can make that screen. But I can go ahead and put this into my bending brake. I'll place that piece of sheet metal in there. I'll go ahead and lock it down. And then I'm going to bend it all the way over. All the way. As far as this brake will go. Just like that. Now, hopefully you guys can see this. So I put a little bend in there. Now that's no longer a sharp edge. All right. And then typically I would just take a hammer. It's a little loud, but now I've flattened that out, and you can do a better job of that. I was just going quick. I've flattened that out. So this is no longer a sharp edge, and it actually adds some strength to your sheet metal as well. So it's good on a couple different fronts. So this is called a hem line. A hem line, you're just bending over to remove that sharp edge, and you're adding a little rigidity. All right. I'll show you on a print that we're going to do on Thursday how that works. All right. Some other things to know about sheet metal. I have a CAD file here to help us explain this. Let's go back to here real quick. All right, so I have a CAD file here. We're going to use the reference. All right, so one thing, every time you put a bend, like when you made your little simple box, you bent those flange edges, the vertical parts, you bent them upwards. Anytime we have a bend, we can't accomplish this. You can't have a 90-degree bend. There's always going to be some radius on it. All right, there's always going to be some rounding on that. Now, one thing, so this picture right here is supposed to represent sheet metal. It's 50 thousandths of an inch thick, and I put a large radius on here just to exaggerate the point. All right, so as you could see here, when I bend this, my inner edge is smaller radius than my outer edge. So what that means is when you bend a piece of sheet metal, you're stretching it or pulling the metal on the outside. It's actually getting longer. And you're compressing the metal on the inside. It's getting shorter. Well, with thicker gauge sheet metal, you can actually see some cracking or tearing and stuff like that when you do this. So it's expected, but just know that you will see that if you're really working your metal a lot. Is what happens. You can get little hairline cracks in there, and they get some deformation of your metal. It's not as clean of a product. You just have to be aware that that's happening. It's like I said, sheet metal is typically not structural, so it's not that big of a deal. But it does also change the size. So, like if I bent this right here, right on that point right there, you can see that because of this, my bend actually goes out a little bit. All right, and it's actually going to be push that out. And for something like our sheet metal box, which would be something like this, right? 5 inches by 5 inches. This inside square was supposed to be 3 inches by 3 inches. But if I bend that out of sheet metal, it's going to be a little larger because it's going to come out a little bit. That for us, that's not a big deal. But if you did have something that really need to have tight tolerances, really need to be dimensionally accurate, there's CAD programs that actually mathematically factor that in, and they'll say, okay, actually don't make this 5 inches, make this 5.06 inches. For all our intents and purposes, we're going to just make it a little simple and just go with this. We understand that we have a tolerance range that's going to be acceptable. What that means is all of you guys will have slightly different size boxes, and that's going to be okay. They're going to be close enough to what we want. But I just want you to be aware that technically we're not getting this true dimensional size right here. With your paper, you might be a little more accurate, but when actual metal in the shop, you can be a little off, but for a lot of parts, that's okay. The next thing I want to talk to you guys about is relief cuts. One of the things we're going to make at some point, you have to excuse some of my stuff here, but is just a toolbox, right? Pick it up, toolbox, good to go. This was all made out of one piece of sheet metal, three separate pieces. We'll work on this on Thursday. But a relief cut, let me go to this CAD file. We'll do this on Thursday, so I'll have this out for you guys. But is these angled lines right here. These are relief cuts. And if you guys can look back on this box right here, that's so when I fold it, I have that edge comes up against that edge, all right? And they don't overlap. So relief cuts, they avoid overhangs on your piece of metal, all right? So if this was not cut at this angle, this triangle would lay over the top of this bottom piece, or vice versa. This bottom piece would lay over the top of this triangle right here. So I want them to come to a clean seam. So I cut these relief cuts so I don't have overhangs and stuff like that. So that would be a relief cut. They allow you to bend it and two pieces come together on a nice clean seam without overlapping. Let's go back to this. The next thing I want to talk about are bend reliefs. So we have relief cuts, all right, are these little angle cuts to avoid metal overlapping each other. And then we have bend reliefs. So let's say I had this CAD right here. Let's say all I wanted to do, let me turn this off real quick. Let's say all I wanted to do was bend this part down. Hold on, let me get these. Now, this is in the middle. All I want to do is bend this part down that's in the middle here. Whoa, don't do that. Okay, sorry about that. All I want to do is bend this part down. So if all I did was cut along this edge right here, and then the same thing on this edge. So if it was a piece of metal here, let's say I just wanted to cut that, and I can go ahead and cut along this line and this line right here, and I could bend that little tab downwards. The problem with that is you often get, when you bend it like that, you're often going to get tearing right here on these corners. The sheet metal will actually tear. It causes a little deformation on the top piece. So on these types of bends, we have to do what's called a bend relief. And you actually cut out a larger section. So I'd actually cut out this rectangle right here. It doesn't need to be curved at the end. I just did that for a dramatic purpose. We'll go with that. And so you would actually remove this material right here and then bend it down. And you have less likely that you'll have any tearing or anything like that. Here's a picture I found online that kind of represents this as well. So this bend right here, no bend relief, all right? As you bend that down, you run the risk of tearing along that edge right there and this edge right here. Where on this side, since you remove some material on each side, you give it, you can allow it to bend and you're less likely to have tearing right there. So that would be a bend relief. All right, so we have hems, fold it over on the edge, fold it over on the edge to make it a little stronger, and you remove that sharp edge that typically comes with sheet metal. All right, we have sheet metal thickness, which is typically talks about in gauges. So you have 3 gauge, 16 gauge, 22 gauge. That's the sheet metal thickness. The higher number is thinner. All right. We have relief cuts, which are these little angled cuts oftentimes, where so when you fold your sheet metal, 2 pieces can come together without overlapping. And then we have bend reliefs, which are these right here that allow some shaping of sheet metal without tearing. All right. Hopefully that all makes sense to you guys. If you have any questions, be sure to reach out and let me know. All right. Good luck, guys.